Hey guys, it's Miss Walker. So for this assignment, what you're going to do is you're going to use the next slide that has some answers to help you figure out what to fill in on the blank slides. If you ever need help, these are our 7th grade Zoom times available every single day of the week. So please don't hesitate to join that or to reach out to me through the Canvas inbox. I do check that probably every 30 minutes to an hour. So on slide 2, you'll see some of the answers here. This is to help you fill out the next slide here, and then you will practice it on your own on the last slide. So what I'm going to do, since you already have the answers here, I'm just going to talk through how we got those answers, okay? What we're looking at is proportional relationships using tables, equations, and graphs, because you can represent proportional relationships in all of these ways. The first we're going to start with is the tables. A proportional relationship between two quantities is a relationship in which the ratio of one quantity to the other quantity is proportional. You could also call that a constant relationship. And I'm going to put my text in, let's see what I like the best. I think I like blue. I'm going to go with blue. So when we look at this table and you want to know, is the relationship in the table proportional, we would see the relationship between y and x. So 60 divided by 1 is 60. Let me move this table down a little bit, or this little text box. And what I do is I'm just going to go through each one of these relationships and see if the rate of change, or that constant of proportionality, is constant. So we have 120 divided by 2. That also gives us 60. 180 divided by 3 also gives us 60. And then our last one is 240 divided by 4. Big surprise, also gives us 60. So we know that the values in this table are proportional, and because the rate is constant, the rate of change is constant. So moving on to equations. A proportional relationship can be written as an equation in the form y equals kx. K is representing the constant of proportionality. In this example down here, our constant of proportionality would have been 60. Okay, that is the big takeaway from that, is when you are dividing that y divided by x, those numbers you get, that is the constant of proportionality. So if I was going to write an equation for this table, my equation would be y equals 60x. What they want you to see here is which equations are proportional. The one that's not proportional, you're going to see right here, because it is in the form y equals kx, but then it's adding something out here. Okay, a proportional relationship is not going to have anything after that x. So notice all of these are proportional because they do not have this number added, or they won't have a number added or subtracted. It says identify the constant. Right here, my constant would be 12. And the way we would write that would be k equals 12, because remember, k means constant of proportionality. On this one, K, our constant would be 0.75. And on this one, our K would be 1/4. Basically, it's saying the y-intercept here is 1. On one of these, our y-intercept would be 0. And so I tell you that because moving on to the graph form of this, we know it's proportional because our graph goes through, the graph has a y-intercept at 0. So let me grab my pen tool. There's a point also at y, or sorry, not at y. There is a point at 0, 0. Okay. And looking at the graph, our change is constant. It's going up 2 over 3, up 2 over 3, up 2 over 3. That is a constant rate of change. The graph of a proportional relationship is always, let me refresh what they say. Oh yeah, it's always a straight line. See, it's a straight line because that constant rate of change is there. So right here, the graph, if it's proportional, it will always be a straight line. If it curves, like curves up, curves down, if it's totally random, those are not going to be proportional. It also goes through the origin, which is 0, 0. All right, so I want you to use this information we talked about to work through these two problems. Dakota earns $8 an hour at his part-time job. So I'm going to get you started here. We have, what we're talking about in this situation is money and hours. And actually hours, since it's a time value, that's going to be our x-axis. So I'm going to put that over here. Hours. And then money would be dependent on how many hours I work. So that's our dependent variable. There we go. Took me a minute there. Okay. Over here, we see the relationship is between feet and inches. So what they want you to do is write the situation, like this is the situation on this example. They want you to actually write a situation here describing the relationship between feet and inches. Okay, so you're going to create a table. You also want to create that equation where you fill in the constant of proportionality. I'm going to kind of give you that little outline there. All right. So, like I said before, if you have any questions, join our Zoom, message me through Canvas. Y'all have a great day.